skeletal system has more than 200 bones. The hard, stiff bones of the skeletal system support the body and protect organ systems. This stiffness, or bone density, refers to the amount of bone mineral in bone tissue, which is shown to be crucial for strength and health.
The bone is made of various layers. The cortical bone is the hard outside part of the bone, and the trabecular bone is the inner spongy side. Bone matter is maintained with the help of two cells, osteoblasts and osteoclasts.
This team of cells maintains the balance in bone density when under the right conditions. Now, you may be wondering, what type of conditions?
The osteoblast sends microcracks depending on the load exerted on the body. They then secrete a substance called rancor, which binds to nearby monocytes. These newly formed osteoclasts then start to eat at the broken bone by dissolving it through hydrochloric acid. This then deposits calcium ions and phosphate ions into the bloodstream. After this bone reabsorption and the apoptosis of the osteoclasts is done, osteoblasts secrete osteoid, which is primarily made of collagen, and restore the bone matter. However, in space, without this constant pull, the bones don't get the same mechanical and electrical signals.
It is found that astronauts lose from 1 to 1.5% of the total bone density in a month, compared to the 1% of bone density lost per year in postmenopausal or osteoporosis patients. So when it comes to space travel, it's pretty much bon voyage for astronauts' bone density.
Therefore, in space, the osteoclasts work faster and break down what seems to be excess bone matter, leading to a net loss in bone mineral density. This weakens the bones and can lead to permanent skeletal damage and muscle atrophy. Take a look at this analogy. Here, cereal can be used to mimic bone tissue. This analogy here depicts what happens when an unexpected force is exerted upon depleting bone matter. However, more research is required to assess the structural integrity of bone matter formed in space. NASA researchers identified resistive exercise like weightlifting and running as an effective way to minimize bone loss on Earth and in space.
Findings from these studies will not only help us to broaden our current understanding of bone diseases and the regulation of bone calcium homeostasis here on Earth, but will also help enable human exploration missions to the ISS and